Hi everyone, welcome back. The learning goal for this video is to be able to describe the electrical charge and location in an atom for a proton, a neutron, and an electron. An atom is the smallest particle of an element that retains the characteristics of that element. So for example, aluminum foil contains atoms of aluminum only. In Dalton's atomic theory, atoms are tiny particles of matter. Atoms of an element are similar to each other and different from those of other elements. Atoms of two or more different elements combine to form compounds, like water, which is H2O, which consists of atoms of hydrogen and atoms of oxygen. And atoms are rearranged to form new combinations in a chemical reaction. It is important to note that atoms are never created or destroyed during a chemical reaction. They're the basic building blocks. Now, atoms contain the following subatomic particles. So within an atom, there are protons, and protons have positive charge. There's also electrons, and electrons have a negative charge. And there are also neutrons that have no charge, and so therefore are neutral. Like charges repel one another, and unlike charges are attracted to each other. And that's going to be a theme in chemistry. You're going to hear me say often, opposites are attracted to each other. From his experiment, J.J. Thomson realized that cathode rays contain negatively charged particles, and those particles, now called electrons, have much smaller mass than the atom. And he proposed a plum pudding model of the atom in which protons and electrons were randomly distributed in a positively charged cloud like plums in a pudding. So this was his theory of what atoms look like. But then Rutherford did his gold foil experiment and concluded that atoms must be small, dense, positively charged nucleus in the atom that deflects positive particles that come close. So in his gold foiled experiment, positively charged particles were aimed at atoms of gold. He found that most went straight through the atoms, but some were deflected only occasionally. And that's what led him to conclude that atoms consist of a small, dense, positively charged nucleus in the center that deflect the positive particles that came close. Because remember, like charges repel one another. And so he had atoms of gold. He had a source of particles. And what he found was that most particles went through, but some, just only a few, were deflected because of the positively charged nucleus in the center of these atoms. So therefore, after those historical experiments, it was concluded that an atom consists of a nucleus located in the center of the atom that contains protons and neutrons. And represents most of the mass of an atom. Electrons occupy a large empty space around the nucleus and have very little mass. And so once again, when you see, for example, this is lithium metal, we see a big piece of it, but that big piece of metal has lots of lithium atoms in it. And if you can see, just looking into one atom, that small tiny dot represents the space taken up by the nucleus. It's very small, and that nucleus contains both protons and neutrons. And everything else outside the nucleus are electrons. They take up this big cloud outside of the nucleus and pretty much make up the volume of the atom, those electrons, but like I said, have very, very negligible mass. Because the mass of a subatomic particle is so small, chemists use a very small unit of mass called the atomic mass unit, which is abbreviated AMU. 1 AMU has a mass equal to 1/12 of the mass of carbon-12 atom that contains 6 protons and 6 neutrons. And for those of you taking biology, 1 AMU is equal to 1 Dalton. And electrons have such a small mass that they are not included in the mass of an atom. They're so like non-significant when it comes to mass. So here is a table summarizing the subatomic particles of the atom. So a proton, I will abbreviate as lowercase p with a plus superscript to remind us that it has a positive charge. The mass of a proton is 1.007 AMU, and it's located in the nucleus of an atom. Neutrons, I will abbreviate as N superscript 0 to remind us it's a neutral charge. The mass of a neutron is 1.008 AMU, and it's located in the nucleus. Lastly, electrons, I will abbreviate as lowercase e with a -1 superscript to represent the -1 charge. The mass of an electron is 0.00055 AMU, so we treat it as just 0. And electrons are outside the nucleus. So go ahead, pause the video, try the study check on your own, and then come back and check your work with me. Which of the following subatomic particles fits each of the descriptions below? Which one is found outside the nucleus? Good, hopefully you said electrons, so let's abbreviate that little e with a negative superscript. What has a positive charge? Excellent, that would be protons. And what has a mass but no charge? Very good, those are neutrons. All right, thank you for watching, and as always, email me with any questions.